Hello students, in this video we will cover electromotive force and terminal potential difference. These are the two terminologies which are very important to understand the topic cell. Topic is very important for CBSE board examination because maybe 2 marks or 3 marks question must be there. It will be there in your examination. So please try to understand this and let's get started. Okay, so we have a cell which is filled with electrolyte. We have two electrodes. One is P, another is N. So these two electrodes obviously will have a potential difference when cell is charged. So we are saying cell is charged right now, and when cell is charged, obviously the potential of P and potential of N will have some difference, that is called potential difference between two cells. But as there is no current drawn from the cell, so in that case that will be represented as EMF. That will be represented as EMF, and the full form is electromotive force. Please don't get confused with this term that it is a force. No, it is not a force. It is a potential difference, and it is a potential difference when no current is drawn from the cell. That means cell is not we are not using cell. Obviously, one thing you need to remember, they can ask you another question in assessment region as well. There are the 2 points, which is A and which is B. These 2 points are in electrolyte, and this A point is very close to P, this B point is very close to N, and there is no current from the cell. What is the relation between potential of A and potential of B? Then your answer must be the potential of A is equal to potential of B. And you can also write that the VA minus VB will be 0. So these two things you need to remember. So when no current drawn from the cell, you can say the potential difference between the two electrode will be EMF. I want to represent this diagram with a electronic circuit as well, or electrical symbols as well. So you can say there is a positive terminal, and this positive terminal there will be a negative terminal, and in between the cell we have electrolyte, and this electrolyte will have a internal resistance. So that internal resistance is R, and we have connected this with a resistance, and this is a resistance R, that is external resistance. So please remember, the internal resistance is R and external resistance is capital R. And right now we have a key, and this key is not closed, this is open. So there is no current drawn from the cell. So the terminal will have a potential difference between the terminals will have a potential difference. That potential difference is known as E, and E is known as EMF, electromotive force. Let's take an example with a battery. This battery is charged but is not being used. So in that case the potential difference between the two terminals, which is positive and negative terminal, so we can write V plus minus V minus. So this is a potential difference between these two terminals. Now you need to give an answer for this. What will be the name of it? Please remember, no current is drawn from the cell, so your answer must be E, that is EMF, electromotive force. Similarly, let's go with another example in which we are using a cell to start a car. When we starting a car, obviously a current is drawn from the cell. As current is drawn from the cell, so in that case you cannot say the potential between a positive terminal and a negative terminal is EMF. Electromotive force is a potential difference between two terminals of a cell when no current is drawn from the cell. So this is very important. And now current is drawn. So I am just drawing this diagram As we close the key, obviously current will start from positive terminal and it will flow through the battery, through the electrolyte. To apply Ohm's law in it, so let's apply Ohm's law, and Ohm's law in it, in this circuit, so EMF is E and total resistance is R plus R, internal plus external. So you can easily write this equation by doing cross multiplication, that IR equal to E. So IR plus IR, this R is capital, one is external, another is internal. And you can write this IR equal to E minus IR, taking it to another side. So this IR is known as terminal potential difference. Terminal potential difference. And please remember, terminal potential difference is the potential difference between two terminals of the cell when current is drawn. And EMF is potential difference between the two terminals when no current is drawn from the cell. This is very, very important. Terminal potential difference. Now I can write the relation which is equal to IR equal to E minus IR, and this IR we will named it as V. So V equal to IR. This is the relation. Okay. So before going into the mathematical relation or derivations, we need to understand few things. We can use the battery and we can charge the battery. So in the first case, we will use the battery, and in the second case, we are actually using the we are charging the battery. In the second case, we are charging the battery. So in these cases, the equation will change. In the first case, we have already discussed that equation will be V equal to E minus IR. And in the second case, as the direction of current is opposite, just check case number 1 and case number 2. As you see, in the case number 1, the positive terminal, from the positive terminal, current is coming out, and in the negative terminal, the current is going. But you can check for this cell, for the cell which is having EMF small e and internal resistance R. In that case, the current is entering into the positive terminal and leaving from negative. That means we are charging the battery. So we are charging the cell. So we are right now charging the cell. And when we charge, so the current is opposite. So we can just switch the direction of current in the numerical value, that is like this, and I can write this will be V equal to E plus IR. So this is the equation when we charge the battery, and this is the equation when we use the battery. Please remember this. So this direction of current is very important to write the equation. And for derivation and for questions, we have to write the equation. So please try to understand how to write the equation. So going ahead, we need to do some practice of writing that equation. We will write potential difference using that equation. Okay, V equal to E minus IR. The example 1, in which the current is drawn from the cell. So just check, current is drawn from the cell. So we are using it. So we can write V equal to E minus IR, as E is E1, R is R1. So, and current is also given, that is 1 ampere. Now what is E1? E1 is 4. You can check. And then we have internal resistance 2 and current is 1. So 1 into 2, that means this will be 2 volt. So this is the way you can write the equation easily. Similarly, you can apply the potential difference across the terminal of this cell, 2 volts. So let's start with this. Again, I'm just finding the potential difference, terminal potential difference across the cell, because maybe cell is getting the current or maybe it is giving the current. So right now the cell is taking the current, so it's a charging case, and in that case we used to write E equals to IR. What is the EMF right now? The EMF is 2 volt. plus what is the current in the circuit is not given, so let's, oh, it is given, that is 1 ampere. So let's write down this, this is 1 ampere and the internal resistance of the cell is 0.5. So what you can write, plus 0.5 and the total potential difference is 2.5 volt. So this is the another case. You can write the equation. We want to write down one more point, which is the potential of A minus potential of B. And this will be, again we can write E plus IR, but in that case this internal resistance will be the sum of resistors, maybe if they are in series you can use it in series, otherwise you can write the combination, the net resistance. So net resistance between point A and point B, including internal resistance. Okay, so this is the very important point, so we can have this. And now obviously, so between A and B we have 2 points, A and B, and check the total resistance between A and B is 0.5 as well as another 0.5 which is internal resistance. We need to include that also, so they are in series, we'll consider. So actually they are in series, so 0.5 will be 1. So EMF is 2 volt plus current is 1 ampere, it is given already, and internal resistance is 0.5 plus 0.5. Okay, so now this you can write easily that it will be 2 plus 1 into 1, the total will be 3 volt. Total will be 3 volt. So this is how you can write the equation. Similarly, we can go for 3 and 4. Now I hope you can write for 3 and 4 as well.